can we build dashboards using FastHTML? Not that static, boring ones, but live dashboards that update constantly with real-time data and beautiful visualizations. And this with only some Python and my 6-step method. Let's look at what is needed, what can be done, how it is done, and how to take it even further. Dashboards has become more and more important over the years, as data, and especially visual data, guides most of us in our work life today. Let me show you how to set up a FastHTML-based dashboard server in 6 simple steps. So what is the simplest we can do of a dashboard? Yes, why don't we stream a digital clock to a client web page, like this one? We have the hours, the minutes, and the seconds ticking away. What will the code look like for this one? In the server code for this one, we see 3 things. We see the page, we see the get function, and we see the generator. So, peg. So in the page, we set up the web page or the dashboard itself. In this case, we only have one thing that is streaming, and this is one paragraph. It contains some text that will later be exchanged for the time. Then we have the codename SSE swap together with the event, and this is server-side events, and the label that we're using for this particular stream. Next up, we have an HX code SSE HXXT set to server-side events. And finally, we have the SSE connect, which point to a route that we're going to connect and get our streamed data from. And next, we have the get function. It's got a route called timesender, the same one that we used in the page. This one returns a streaming response with media type text event stream, and this is typical thing for server-side events. What it really returns as a message is this time generator. And that is the third thing that we're looking at, the time generator. This is a generator that it takes the current time now and formats it to hour, minute, and seconds. It puts it in a paragraph, and this paragraph should keep the time update event. Now this server-side event should also be the second parameter to the server-side event message is the event which we set to the label time update event. So this message is yielded, and then we wait for the next time to happen. And in this case, I just sleep for 1 second before the next time is generated and sent off with another event. Now, if you're not familiar with generators, they are just like iterators, but they never run out of content. They will be giving you a value for eternity, just like a randomized number generator, for instance. Now, the thing we have recognized in this part of the code is a pattern that we can reuse later on. And I call this the peg pattern. The page, the get, and the generator. There are a few options when we're choosing technology for streaming data from the server to the clients. And basically you can choose to use any of them. For the first one, we have web streams. They are double connected, so you can stream data in both ways. And they are practically used when we're doing chats or team collaboration tools. But they are a bit low level and you need to handle quite a lot of events like connecting, disconnecting, reconnecting and keeping a state of them. And for the second, we have client pull or polling. And using that technique, we get a lot of requests from all the customers into our server. At least if we're serving many clients. And for the third one, we have server-side events. Those are one-sided, sending data from the server to the clients, which is exactly what we're looking for with dashboards. They are also fully integrated into FastHTML via Starlet SSE. So in the end, I choose to go for SSE or server-side events in this rundown. Partly because it fits very well together with the dashboard application, and secondly, they're very good integration and very easy to use. So comment below with what technology you would use for your dashboards. Then, as a next step, what about streaming live data into a graph or chart? In the FastHTML gallery, there is an example using Altair charts. So let's go for that one in this example. And what should we show? Well, how about the CPU load of my local PC while I'm recording this one? Should be fun. Let's start at the imports. The first four were already used by the other example of the clock. They are used to setting up FastHTML and using server-side events. New here is the stuff from FH Altair, Pandas, and Altair itself. Next, we'll look at what scripts are included in the HTML header section. We set them up and make them a part of the initiation of FastHTML app. Here we have SSE links that is used to handle the server-side events, and we also have Altair links that is used to set up the charts of Altair. And then let's peg. The page has a new card with a div in it that's used for the chart. This one has an SSE swap set to graph update event, or the label that we are using for these server-side events. We set the hx to SSE just to indicate that we're using server-side events. And finally, we give a route to connect to where the data is coming from, the SSE connect, and we're using graph sender as this route. Jumping to the get function with the root graph sender. This one looks very much like the other one, except it's using the graph generator for the messages. And then we have the generator. I have my plot data as a list, but as a global variable with a list. And as I'm running Linux, I can use the top command to read how much CPU load I got at the moment. And inside the generator's eternal loop, we read this CPU load from the top command. Then we need to translate this one to a float value. And finally, imported last in the plot list of graph data. I keep my list limited to at most 10 values. You can do longer or shorter, whatever you choose. But I don't let my list grow infinitely. After that, I use pandas to define a data frame, where y is the plot data and x is just the range of the plot data. After that, it's time to set up our chart. We're using Altair chart and give it our data frame. We set this mark to line as in line chart, and then we encode the x with x and y with y. And in the end, we set some properties on how big we want it. 400 times 200 pixels. Now we need to package this one for the SSE message. So we define an SSE message with a div, the old div from the page that we will replace, containing this chart, but rewritten by the function Altair to FastHTML, so that everything is transported in the right way over to the client. We keep the SSE swap to a graph update event and this SSE message, and we need to set a label on the message itself, and this is graph update event. Now that is what is yielded and sent off to the client. And then, in this case, I wait for 5 seconds before starting all over again, reading a message with top and generating the div that contains this new updated graph. Now, what will this look like in our windows? Since we update this every 5 seconds, it doesn't really fill up that fast, but after 10 times 5 seconds, we have a full 10-point graph. We can also choose to speed this up if we want to. And looking at it, my laptop is working a bit hard at the moment since I'm recording this and running this server as well, so it seems like it's standing just below 30% on average. Now, isn't this exciting to see that it's live? With this method, anything can come alive.
That was so disturbing.
Now, that was line charts. What about pie charts? Why not make a pie chart showing the disk usage on my laptop? Now, how would we peg that one? The page is almost an identical copy of the line chart. We're using one unique label for the disk update event, and we're using one unique route for the disk sender. And what about the get function? Yes, we have seen it before. It's look exactly the same, except it is using the disk generator. And finally, the disk generator. This one is using the dfh total command and sorts out the actual line that I want to use. From this one, which contains total, size used and free, and also a %, I only look at the used and the free. These two values are put in a data frame. These two values is put into a data frame, which is put into a chart. And here we set the type of it to mark arc. In this one, we use the angle as values and color as disks. The disks are used and free. We do it of an equal size. The SSE message is put up in exactly the same way, using Altair to FastHTML chart, and we use the disk update event label. We yield the result and sleep for about 30 seconds. And I take 30 seconds on this one because my disk doesn't really update that much over such time periods. Now, what will this look like? I need to start scrolling a bit. Yeah, it really looks like I have about 44% free on my disk. That's quite impressive, thinking about how long I have been using this computer. What if you don't like to have your charts or graphs standard white with black lines? Let's quickly try to change the background color for them, just to see how it's done. All that is needed is adding a configure option when we define the chart. Here I have set the background of the first one to, guess what color? Just to make this interesting, I also changed the color of the pie chart to another color. Guess what color that is? Now what will this look like? Yes, I set teal background color for the line chart and a pink one for the pie chart, just to be brand color to my channel. So check it out. Maybe not the best color matching, but all that is up to your imagination to change. We now have our graphs exactly as we want them. Now this was changing background color for the charts, but you can also tweak the most things on these graphs. How and if to do the legend, what the axis will look like. You can remove the mesh of the line graph, and you can color code the values in line graphs. And on, and on, and on. For any kind of tweak you want to do, see the Altair documentation. I have a link in the description. Then we're in for the last, or maybe rather the first step that we need for the 6-step method, respeg. To be able to import a library, we need to have it inside our Python environment. These are often defined in a text file called requirements.txt, and they are often fed to the pip command or pip-e requirement.txt. So what's in my requirements file for these examples? There are only 3 things that I need to download to my Python environment, and that is FastHTML as is, the FastHTML Altair thing, and pandas. The rest pip will handle for us. So this is the R in the respeg method, the requirements. Then we need to check the includes we need. And in this example, I'm using these 7 ones. But if you're not looking into datetime or not using Altair, they all fall away. So these depends on what packages you are using. And this is the I in respeg. Then we have the script tags for the header section of the HTML. Basically, we're using it to include JavaScript libraries for things like the graph library and server-side applications and other stuff that you need. And this is the S in Rispeg for scripts. And then we have the page. And that one needs room for what we will fill this dashboard with, and how we sort them out and place them on the screen. Since we're streaming, we need references to SSE or server-side events, we need a label, and we need -XX sender, something to hook up the stream to. And this is P for page. And then we have the sender function that the client connects via. And this one looks very much the same for all, it just contains different generators. And the get is the E from Rispeg. And finally, we have the generator. A generator that forever gives new values, and they should be packaged in HTML content that we can replace using HTMX on the client side. And for that, we're using the SSE message and targeting the event label. There we have it, the 6-step method of Rispeg. How to make server-side dashboards using FastHTML. Now, I've been using Altair charts here, and look at their gallery to see what kind of graphs you can use. They have simple charts, bar charts, line charts, area charts, circular plots, scanner plots, uncertainties and trends, distributions, tables, and maps, and some interactive charts as well. Even though I never tried them, there's also some more advanced calculations available. So look into the gallery, link below if you're interested in Altair charts. But Altair charts are not the only charts that you can choose to use. Here is a list of 10 other types of charts that you can try out to use. I haven't tried them, but give them a go. They might work better for you. Just imagine what you can do with these. Now that we have evaluated everything's FastHTML, simple multi-page application, single-page application, performance databases, styling, and dashboards. Where to go next? Yeah, I think I still like this framework, so let's start doing actual applications with it. What and when? I'm not really sure about that now, probably sometime during the Christmas time. But keep an eye open and look at it when I release the first application video. And do comment below what you would like to have covered, apart from authorization and hooking up to a payment integration. That must be in it. But anything else, let me know. So to not miss out on any FastHTML content, do subscribe so you will be indicated. So if you have missed any other basic functionality rundown that I made on FastHTML, you can check them out in the description, and one of them will be suggested to you here in the suggested. So just click it and I will see you there in just a second.